Welcome to the project demonstration of solar power measurement system by using PIC microcontroller. So in this version, we developed a mini version to monitor the 12 volt solar panel and 12 volts battery. So whenever the battery voltage is discharged and it is below, when it is ready to charge, and at the same time it will check the solar panel voltage also. So when the battery voltage is less and when the solar panel is sufficient to charge the battery, then our microcontroller will switch on this electromagnetic relay to provide the voltage from the solar panel to the battery. So the voltage of the battery and voltage of the solar panel continuously monitoring on the 16:2 LCD screen, so which is interfaced to the PIC 16F72 microcontroller at the pin numbers B2 to B7, and the battery voltage interfaced through the potential divider circuits. So here we are using 10:1 potential divider circuits. So this is the 10:1 potential divider circuits. So voltage sensor, and this is the voltage sensor for the solar panel, this voltage sensor for the battery. So here you are using the 10 kilo ohm and 1 kilo ohm are connected in series, so which will act as a potential divider circuit. Means in order to measure the voltage of 12 volts of DC, controller can handle up to maximum 5 volts. Means we should make this 12 volts below the 5 volts. Means we should make a voltage dividing ratio. So now here using 10:1. If the controller provided with 10 volts DC inputs, then the potential divider circuit will divide that into 1 volt, and inside the microcontroller we programmed in such a way that according to the potential divider ratio we need to multiply that with 10 volt. So then we will get the 10 volts. So that is the input voltage from the battery. So if it is getting the 12 volts, controller will get only 1.2 volts. Again in the programming we multiply that with the 10 and we'll get the exact voltage of the input voltage. Same for the solar panel also, it's a potential divider circuit. So on this motherboard we can see the microcontroller which will take care of input and output module, crystal oscillator to provide the clock frequency to the microcontroller in order to execute the instructions. So means each instruction need one pulse so that controller can execute 20 mega instructions per second, and the third one is a reset switch. And so here we have interfaced the battery voltage sensor at A1 pin, solar voltage sensor at A0 pin of our microcontroller. So let us see the demonstration. So if you want to charge a battery from the transformer, means if the battery is discharged and there is no sunlight available but we need to charge a battery, so then by using 230 volts AC inputs we can charge a battery. So it will be fully charged in a duration of maximum 8 hours. So we should keep the charging for 8 hours, and thereafter automatically these diodes will block the current flow from the transformer charging circuit to the battery. So here these diodes will act as a rectifier, so which will rectify the AC which is coming from the transformer and it will be the DC, and after this capacitor we will get the pure DC voltage. So that is sufficient to charge our battery directly. So here I am charging the battery directly from the charging circuits, but here we are charging the battery from the solar panel to the charging circuits through the battery, through the relay to the battery. So this is charging flow from the solar panel to the battery. So based on the availability voltage from the solar panel and the charged voltage inside the battery, we are going to controlling the charging circuits through this electromagnetic relay. So now let us see the demonstration. So this is the main on off switch on. So welcome message will be displayed on the LCD screen, and then after we can see the voltages on the LCD. So as of now the battery voltage is 12.2 volts and the solar panel voltage is 1 volt, right? So but actually we should get the voltage above 13.5, then automatically this particular relay will get switched off.